Hi, this is Miss MoHearn, and we're going to start cellular respiration. Plants go through photosynthesis to make glucose. They make it, and then they need to break it. We eat it, and then we need to break down glucose. So plants have both chloroplasts and mitochondria, and humans have, and animals have mitochondria. So our very first step is called glycolysis. Lyse means to explode, and the glyco is the glucose molecule, our friend glucose. Let's take a look at glucose. It is C6H12O6, so there are 6 carbons, 6 oxygens, and 12 hydrogens. C6H12O6. Every time you see a bond, there are electrons there. I don't have enough papers to put all the electrons, but basically in the explosion of glucose, we are releasing energy to then reform it into the currency of the body, which is ATP. So we're going from glucose energy to the energy in ATP. So what do we have to do first? First step is glycolysis. We are doing respiration, and glycolysis occurs outside the mitochondria. No oxygen is required. No mitochondria is required. Everything on this planet does glycolysis. Yep, even bacteria, because they don't have a mitochondria. Bacteria are just doing glycolysis. We have a mitochondria, so we can do many more steps inside the mitochondria. But this is step 1, glycolysis. Take that yummy glucose and let's lyse it. Let's explode it. Oh no, I can't explode glucose without spending 2 ATPs. What? You're telling me I have to spend ATPs? You gotta spend ATPs to make ATPs, I'm telling you. So we've spent these ATPs, rearranged glucose a bit, and then once we have exploded those, we have rearranged rearranged glucose. You can see in those first 2 steps, I know this looks super scary. You do not have to learn all of this. This is what actually happens though. Rearrangement, and then the explosion of glucose into 2 pieces. And those 2 pieces are called pyruvate and pyruvate. So glucose no longer exists. What happens when you break bonds? Aha, you free these electrons. And who's going to come and grab those electrons? Well, that is our electron babysitter called NADH. So it's without electrons, it is NAD+. Once it grabs electrons, you now call it NADH. And it is going to make its way to the finale, to the electron transport chain. Goodbye. So you can see here, NAD+ will grab electrons, will grab hydrogens also that have been ripped up when we split glucose in half. In this process, we actually make 4 ATPs. We're freeing so much energy. Remember, we spent 2, so we actually only have a net gain of 2 ATPs at the end of glycolysis. So what have we made? We've made a net of 2, and we've made NADH, which will go to the electron transport chain, and 2 pyruvates. We are on to the intermediate step and the Krebs cycle. But first, the question is there oxygen? If there is no oxygen, we are stuck here in glycolysis, and we will go through fermentation, lactic acid fermentation. If there is oxygen, then the pyruvates may cross the membrane. Oh, remember there are 2 membranes. We'll cross the outer membrane. Pyruvate 1, pyruvate 2. And you will see in the next one what happens to our friend pyruvate. Remember, our goal is to completely explode. So can you predict what's going to happen to these carbons here? These carbons, ooh, they've got juicy electrons there. They've got, oops. Let's turn that over. They've got some electrons that we want to rearrange for ATP. So can you predict what's going to happen next? See you in the next video.